Okay, let's start. Let's start now. I hope I can finish the inheritance today. If you want to read the design books, please actually read the GUI, the chapter that covers the GUI section. So I think that's chapter 15, if I'm correct. Let me just check. Yeah, that's chapter 15. So I want to cover the Java GUI section. I think this is a very important section. So so far we have talked about the Java class and the derived class. Now, the purpose of the derived class is to, define a class which is a subclass of the class which is called the base class. Now, idea behind this is, in many times, you define a class, for example, like automobile, and then you can define all the field variables, the attributes, and all the methods defined for the vehicle, for the automobile. Now in many cases, you want to define another class, for example, like sedan, SUV. So you can define a sedan SUV as a dedicated class. So you can define a class called a sedan, and then you can define all the field variables and all the methods for the class called a sedan. And then you realize that there's a relationship between automobile and a sedan. And so sedan is a type of automobile. So that means you can interpret the sedan as a subclass of the general class automobile. Now you can define all the actual attributes for automobile, like the maker, the year, the model. So, and also you can define a field variable like a color. What's the color of the vehicle? So you can define all these attributes. And then you find out if you want to define another class called a sedan or another class called SUV. Now, sedan, the class sedan, should have all the attributes that the class automobile has. So the sedan also has a maker, model, year, color. So it contains all the attributes that you define for the automobile. Now, the reason for this is because sedan is an automobile. So sedan is an automobile, or SUV is an automobile. So everything you define for automobile also applies for the sedan or SUV. However, the opposite may not be true. So you can define some attributes for SUV, but it may not apply to the general automobile. For example, like SUV, you can say define one of the attributes case says whether this is a four-wheel drive or forward-wheel drive. So it's kind of like a FWD or AWD. So, or for most of the SUV, you may also actually have another type called crossover, right? But this may not be the case for general automobile. And also, if you define another class called a pickup, so pickup is an automobile, so it has all the attributes the automobile has. So you can, however, you have some kind of attribute like whether it's a half cab or full cab. This only applies to the pickup for the truck, okay, not for the general automobile. So, because of this, Java provide a way to define something called a derived class. So a derived class is basically a subclass of the base class. So it so derived class is a base class, but not the opposite way. So now we actually use the example of bank account, right? So that's a base class. So we define a particular class called checking account. Now, checking account has all the attributes that the bank account should have. Bank account has a balance. Checking account should have a balance. Bank account has an account owner. Checking account also has an account owner. But check account has something else. The general bank account may not have. Okay. We also define savings account, which is also a type of bank account. So now you can define checking account as a derived class of bank account, savings account as a derived class of bank account. Okay, now, so we actually discuss all these methods defined for the checking account, defined for the bank account. We also actually use some kind of, you know, uh, tool to define the method for derived class. Okay, so one of the things that the Java actually provide is you can define the same method in the derived class as the same as as in the base class. You can use exactly the same name and the same parameters. In that case, when you call the method in checking account, you're actually going to call the method in the checking account, not if you have the same exactly the same name. So that's called a method overriding. So the checking account has a deposit. Bank account also has a deposit. Now, in checking account, the deposit actually going to actually change the balance based on the deposit amount. But also checking account also going to update the transaction count, right? Which is not actually, which does not happen in the general bank account. Bank account may actually include all different types of accounts. So only check account actually have some kind of feature like a transaction count. So you may, the customer may get some kind of free transaction count, like so they provide like a limit, like every month they're allowed to make a transaction for 5 times without being charged a fee. And after you actually make more transactions, then the bank are going to apply the fee for each transaction. And then next month, they actually provide the same kind of feature. So then the customer can make another actually 5 free transactions for the next month, and then afterwards they will be charged a transaction fee. Okay, so in that case, you have to define a deposit in the checking account, even though the deposit is defined in a bank account. Now, in that case, it's called overriding. It's called overriding. Okay. So I have post these bank account example on the Blackboard. And in addition to the checking account, I also, posted the savings account, the example for the savings account. You can check it out. And also I define a method for the bank account. The method I actually added was called get account info, which was not there in the previously. But the get account info basically going to return, once you actually call get account info for a particular account, then it will give you the current balance and who is the owner. Now, then I also override the get account info in checking account and also in savings account. So get account info also were overwritten in checking account and savings account. So it basically provides a similar information like a bank account, but for checking account, the get account info also returns, besides the balance and owner information, also it's going to return the number of transactions, because it gives the customer some kind of view how many transactions you have made at this moment. Okay. And also for the savings account also has some kind of interest rate related to it, because people put the money in the savings account because they are not going to actually change frequently. So normally the bank will give you some kind of interest, even though the interest rate is not really high. But why not? Because you put the 5,000 deposit, $5,000 in your savings account, and after a year, if the interest rate is 3%, then you will at least get a certain amount of money, right, in your account. So please take a look at the bank account example I put in there in the Blackboard. Okay. So now, so far we have talked about the overriding in the derived classes. And remember, in the past, we actually talked about another terminology. It's called overloading. Now, can you tell me what's the difference between overriding and overloading? What does overloading mean? What does the overloading mean? Now, for overloading, it's basically we're talking about different methods in the same class. Okay. For overloading, we're talking about different methods in the same class. And these methods has the same name or have the same name. Okay. These methods have the same name. Okay. Now, it's actually defined as in the same class, and we use the same name. But in order to make these methods different, you have to provide a different parameters, and we call these signature. Okay. So basically, overriding basically means you can define methods in the same class with the same name and have different parameter types. Okay. Now, overriding is basically between the base class and the derived class, the subclass. Okay. So a derived class member method takes the precedence over the base class member method with the same name and the parameter type. So you actually define exactly the same method, use exactly the same method name and the same parameters. Now, if I call this method in the derived class, you are not calling the method in the base class. You are calling the method in the derived class. Okay, so derived class basically going to override whatever defined in the base class. Now, if you call a method which is not defined in the base in the derived class, and but it's defined in the base class, then the Java can automatically call the method in the base class. Okay, that's by default. Okay. So overriding is performed if derived and the base member methods have different parameter types. Okay, overloading. Okay, so overloading also going to be performed if you define the same two methods in a base class and also a method in a derived class, but they have the same name but different parameter type, and the Java still view this as a different method even though the name is the same. Okay. So now if you try, once you say, okay, I define a method, okay, I override a method, for example. Now, if in a base class, which is business, and the restaurant is a derived class or subclass, now restaurant extends the base business. So now, if I have a method in a base in a bit class business called a get description, this is a method basically you're going to call to get what's the description of your business if that's defined in the base class. Now, so now in a restaurant, in a class restaurant, which extends the business, which is a subclass of business, I also define a method called description. But if I want to call the get description in the base class, what about if I call get description in the base class? How should I do it? In this case, you have to use something called a super dot and then get description. Now, if I see super dot get description, that means this is the get description method defined in base class. Otherwise, it's going to cause confusion. If I actually miss the super, just say get description, which is defined inside this override method. Okay, so this is going to confuse you. The Java going to say, well, you want to call get description, and now you have a get description in both the derived class and the super class and the base class. Which get description you want to call? And Java going to interpret this as the get description method in this derived class if you don't put the super dot get description. So if you want to call the overwritten method, then you need to put the super dot, then the method name. Okay. If you don't put the actually super dot or the method name, by default, Java gonna think that you are calling the overriding method, which is defined in the subclass, in the derived class. But if you put a super dot, then the method name, you are calling the same method in the base class or in the overwritten class. So that's the major differences. Okay, so I think I'm done with the relationship between base class and the derived class. Okay. Now, the next thing we're going to talk about is the object class. Okay. Now, object class, in Java, there's a class name called object. That's a class name. Okay. So this object class is defined in Java. But most time you may not notice, there's such a class. But there's a class called object. Now, by default, this built-in object class serves as the base class for all other classes. So it's the base class of all the classes you define. Even though when you define your class, like a public class bank account, right? So you define the bank account class. Now, bank account class has no base class, because if there's a base class, you will probably say bank account, then extend, right? Same thing. Extend another class, then bank account is a subclass of the other class, or the base derived class of another class. But bank account, in our example, there's no such a base class. Now, this doesn't mean that the bank account has no base class. Bank account has a base class. Even though you don't explicitly say bank account extends the base class, but there's a base class, and this base class is called object. So object is, if you don't specify a base class, by default, the base class is the object class. Okay. So all classes, including user-defined classes, are derived from object. Okay. And implement object methods. Okay. So object class is defined in Java. And every class should be a derived class for object. Now, in object class, there are two methods. One method is called toString. The other method is called equal. The toString method returns a string representing of the representation of the object. Okay, and the equal is another method. Now, what does that mean? So bank account also is a derived class for object. An object has these two classes. So that means if I have a bank, if I define a bank account, then I can call toString method, right? Okay. Let's take a look at the example so that I just post on the Blackboard. Okay. Okay, so now remember we define the bank account and the checking account, which is actually derived extended to the bank account. So the bank account is the base class for checking account, but looks like again bank account has no base class, right? But as we mentioned, that the bank account has a base class, and the base class is the object class. And for the object class, there are two methods, toString methods, and also the equal method. Okay. So now, if bank account is a derived class of object, so looks like I can still, even though there's no method called toString defined in the bank account class, but I can still call a method like a toString, right? So let's see. For example, in this case, I define actually 3 checking account my checking account, my savings account, John's account, and checking account, and a checking account. Okay, so I actually defined 4. And the first 3 I put in the array list, right? So I have put in the array list. So now let's see. So let's forget about array list. So I'm gonna actually get rid of array list. Okay. So let's see. I defined the bank account. Okay. So I delete this one. So I also delete the John's account. So I only have 2 bank accounts. One is bank account, my saving account. The other one is checking account, which is a derived class of bank account, right? So now if I do this, so let's say my saving account. Okay. Dot. So my saving account is created. The owner is Mary Johnson. But I call the constructor, which only actually assigned the owner, not the balance. So the ID for the balance should be 0. So let me say I deposit, okay, say $1,000 into my saving account. So let's call my saving account, my savings account, dot get account info. Okay. So where's get account info defined? The get account info, as I mentioned, that I defined the get account info as this. It's just to print out the account owner and the balance. Okay. So let's actually compile it. Hmm. Okay, my savings account get info. Oh, I think I did something wrong. It's ACCT, not ACCOUNT. Hmm. Still, I got something wrong. In my main, it's 10. My saving, my saving S. I missed the S. Well, it always happens. Okay. Okay. Now I can my. So you can actually see that you know the first this gonna return account owner Mary Johnson. Account balance is 1,000 because I deposited 1,000 there. So now the second one's Mary Lou and Mary Lou. That's because I printed it 3 times for the checking account. So it's not a saving account. So let me separate this. So checking account. So then you can see everything below that one, it's basically the other account. Okay. So yeah, the first one is this. Now one thing I want to explain that because my saving account, which is a bank account is derived class for the object. And there's a method called toString of the object. Now I want to see what this toString gonna bring you. Okay, so what does the toString gonna actually eventually, when I execute the toString, what happens? So let's say my savings account dot toString. Let's see what happens. Okay, let me type return. So type a print len just to provide a return. Okay. Okay, let me clean up everything. Okay. Oh, let me just compile again. Looks like it does not return anything, right? So Mary Johnson, account info, and the next one, it does not print out anything. Okay. So, but this method is there. Okay, does not do anything. So now, sometimes if you want to actually get some information about the class of the toString, you can override the toString in the object class, okay, to put your own contents. So that means in the bank account, you can actually create a class called override, okay. Let's see, what's the class defined? So toString, you can actually say print, okay, I'm gonna call get. Oh, in this toString, I just call this method, and then let's see what happens. Oh, so this should return some kind of value. String. In the object, you have to actually exactly follow the what's defined in the object. Okay. So let's see. Let's say um, the font is account owner is so that's the account owner. Let's see. Yeah. Okay. So then let's try. Oh, I should not do this. is working. So then you can actually, you can override the toString in the object class. So even though this does not do much, just a call the get account info, but you can actually do this. So the object class basically is the base class for all classes. If you actually cannot find any base class, then by default, object class is your base class. Okay. So for example, so one of the method defined in the object class toString method. So if you define your own class called object printer, and then that's the main method, and then you can say object, because object class, so my object is a type of object, okay, and then you define a class called integer. Remember, that's the what's this called? It's kind of you want to actually make a primitive type like an object, right? So you call it integer. It's called a wrapper class. Okay, so integer, the wrapper class for the integer. So you can define num as an integer class, and the business as another class called a business. So you basically have defined two variable, actually three reference variable. One is my object. The other one is num, which is integer, and some business, it's actually a type of business. And then you can actually say print out, say my object toString, num toString, and some business dot toString. So you can actually, even though the toString is not defined in business, but you can still call that toString because toString method is defined in the object class. The object class is the base class of all other classes. So the method in object class can be called by any method. So now, if you don't actually override the toString, sometimes the toString gonna give you some kind of interesting value. Sometimes it doesn't give you anything, just like the case in the bank account case, it does not provide anything, but the output going to be the toString for the integer num. It will basically num.toString going to give you the value, which is 100. Okay. Now the other two methods, the toString going to give you some kind of interesting. It just say, oh, this is the object class, and in some base business they say this, oh, this is a business type class, and what's this value here? This basically gives you the memory address of this object, some business. Okay, so you define some business as an instance of business, right? So this basically gives you the memory address. Okay, and this is actually the memory address of this my object. Okay, so the information is kind of useless, because why you want to know where this object is stored in the computer memory? I don't care, right? But that's what the toString gonna give you. So which is kind of odd. So most of time you want to override the toString method in the derived class. Don't use the toString, which is defined in the object, because it really does not give you anything. So the user-defined class can override object as toString. So you can define your own toString method. If the user-defined class is also a base class, and a derived class does not override toString, then when the derived class object toString method is called, the toString method in the base class is executed. Okay, so if you have your class, say bank account, This is my class. And then I define checking account. Okay. Now, if I actually define override the toString, if I override the toString in bank account, so because bank account has an object is the base class for bank account. Now object has a toString, right? So I can override the toString in bank account. But if I call toString in checking account, I basically that means I'm calling the toString in bank account, not the toString in the object. Okay, so I always call the base class, not the object class. So that's basically what it means. Okay, so it's always good idea to override the toString class, a toString method. Okay. Now let's talk about another topic. It's called polymorphism. Okay. Now Java support the concept called polymorphism. What does polymorphism mean? Polymorphism means basically polymorphism refers to to determine which program behavior to execute depending on the data type. Now, if you look at the dictionary, polymorphism basically means basically a same object with different forms. Okay, the same object with different forms. Now, so the polymorphism basically give you some kind of flexibility. Now, method overloading is a kind of compile time polymorphism. Okay. Now, there's another type of polymorphism called runtime polymorphism. Now, let's check the example. Okay. So let's take a look at the example of the polymorphism. And you will probably see what does it mean. Okay. I define a couple of classes. Okay. So one of the class I define is called animal. The class called animal. And then I have two field variable. It's protected. So that means it can be called by the derived class, right? So one is the animal name. The other one is called a sound. Okay. So this is actually these two are the constructors for the animal, right? This is a constructor. I can call animal, and this is a default constructor. The default constructor says, if I call animal, I don't provide any parameters, then the animal name will be assigned like a cool guy. Okay, that's the animal name. If I just call animal without provide a name, and then the cool guy is the name. Now the sound, I even don't know what kind of animal is this. It's just a general animal. So what is a sound? Okay, so I don't know what's the sound. So I just say the sound equals the animal is making a sound. So what sound? I don't know. Okay, so then I define a method called there's another actually constructor. In this case, I provide a name. So, and then the name has been changed, but the sound, I still don't know what's the sound. Okay, so I just still use that variable. And there's one method in this class called make sound. Okay, so make sound basically gonna just print out the value sound. Okay, print out the value sound. So now if I define instance of animal, then what's the value will be, which value will be printed out? What's the value of sound? It's animal is making sound. So when I print this out, what statement will be printed out? Think about this. Okay. Now then I define another class called cat. You know, now I make a cat a derived class of animal, right? Cat is an animal. So then I actually call the default constructor cat, and then the name will be called kitty. Okay, because the name is already defined in the animal as a protected, so I can call the name kitty. And the sound, I just say mew. Okay, that's a cat. And there's another actually constructor also called cat, but this time I provide a name. And then I just say I provide a method called make sound. Okay, so make sound is actually also defined in the animal class, right? It's a base class. But now I also define a make sound method. But this time I'm gonna actually just print out first the name, which is kitty, talks. Okay, name talks, and then sound. So which value will be printed out? If for a cat. And then I define another method called horse. Horse actually extends animal, and then I call the albi, and the sounds. I don't know how to sound this. New, and then that's a default constructor and another constructor. And then I override the method to make a sound. I got called uh, sound name makes such a sound. Okay, so that's a different, you know, let's override the base method. The base method just print out a sound, but now I print out name plus makes plus sound plus sound. Okay, and I define the main method over here. In the main method, it's a statical, so I define a method called animal, a horse, new horse. Okay, so I define a variable called animal. Okay, now I define another animal, a cat, and I call the constructor cat. Now, do you see what's strange? What's strange about this? What's so strange about this? Does everybody know? Can you tell me? So when I declare a horse as an animal, okay, so it looks like a horse is a type animal. However, when I call the constructor, I don't call the constructor for the class animal. I call the constructor in the class horse. Did I do this before? Everyone has any opinion or anyone want to say anything? let's see. Okay, let's see. In this case, I define animal. And I define two derived class, cat, horse. Now, typically, when I create the object of animal, I'm going to say animal. For example, a horse. And then I don't normally say new animal, right? And then I call the constructor of the animal. Okay, a horse is an animal. That's okay. Now, in this case, I define a horse, let's say horse 1. I call the new, but I call the constructor in the horse class. Now, what do you think? What's the difference? So is a horse 1 is the object of horse, or is an instance of a horse or instance of animal? Let me ask you a question again. If is the horse 1, the second one, is an instance of an animal or instance of a horse? Is an instance of a class animal or instance of a class horse? Do I hear anyone? Okay, that's good. Yeah, I hear. I see the message from Alex. Okay, a horse 1 would be an instance of a horse, but it's also inheriting animal. Yes. Now, then that's one point. The other point is, now what difference does it make? Okay. Now let's go back. Let's go back to let's go back to the example again. Now, so let's say if I actually say okay, let me actually just type again. Say animal dot horse equals new. Let's say I'll be so I define a horse as an animal, and I call the instructor constructor animal, and the name is Albi. So the second one I use horse 1. Okay. Okay. So which is actually declared as animal, but I call the constructor in the horse. And the cat is declared as an animal, but it's actually called constructor cat. So then let's say I call a horse so I call make sound. The first one for the horse, second one horse 1, third one is a cat. Okay. So even though all these declared as an instance for animal, but when I call the constructor, the first one called the constructor of animal, the second one called the constructor horse, the third one called the constructor of cat. Let's say what's the difference? Say Java C and horse.java because the main method is in horse. What do you expect to see? So it looks like I'm gonna print out 3 lines. Each make a sound. They're gonna print out something. What's the first to actually print out for a horse? It's just a call. Which make sound will be called. The make sound in the animal will be called, right? So make sound in the animal will print out what? So let's say, so the first print out is animal is making a sound. Okay, even though I call it a horse, and then there's a name called Albie, but the printout says animal is making a sound. So it's a generic printout statement. Now the second one, even though a horse won, I called, I just call the constructor in the horse, and then it just print out like Amber makes new sound. Okay, and the third one, cat. Okay, it's declared as an animal, but I call the constructor in the cat. It just says Squeaky talks mew. Squeaky talks mew. That's exactly what the make sound is defined in the cat, right? In the cat. So it says name plus talks sound. So that name is Squeaky, because I when I declare I use my own name Squeaky. Squeaky talks. The sound is mew. Okay, so Squeaky talks mew. Okay. Amber makes new sound. Okay, so Amber makes new sound. I call this. So now this is called polymorphism. Okay, this is called polymorphism. Why it's basically it means that when you declare the method, when you declare a variable, I declare as an animal. It's a base class type. It's general animal. But when I call the constructor for this particular animal, like a horse one, I call the constructor in the horse. So then, even though it's declared as a general animal, but a horse one eventually becomes an instance of a horse, not instance of an animal. Actually, it's also instance of an animal because animal is a general, right? Derived class is an animal, right? Horse is an animal. So, but it's a specific animal. It's a horse. So I can actually call the method defined in the horse. Now, if I use cat, even declare as general animal, but when I actually call the constructor in the cat, so this cat is actually an instance of the class cat, also instance of class cat. Now, this is called a polymorphism. So the polymorphism basically gave you some kind of idea that now, so when you declare a class instance, declare a variable, you can declare as a general variable. But when you actually call this assigned object, you can assign a subclass object. So if I actually say this, you may probably not clear enough, but you can say, let's say if I do this, So I declare a horse as an animal. Okay. And then I declare a horse 1 also as an animal. Cat also as an animal. Okay. Okay. So when I declare these three actually reference variable, they are all actually animal. But when I call the constructor to assign the object to this animal, so I can actually call this a horse 1 by calling the horse, which is a derived class of animal. So a cat is actually declared as a cat. So then if I actually call the constructor horse, the horse 1 becomes a horse. If a cat becomes a cat. So what about if I just say the first one, I say an animal, right? An animal. Okay. So now I'm gonna say an animal equals a new animal RB. So this is basically the same, no difference. Okay. Oh, I forgot the semicolon. Hmm? Oh, okay. So an animal. Okay. So animal is making a sound. So the first one still making. But if I change this, I call the horse. Okay. Now what happens? We're gonna say RB makes neon sound. So now RB becomes, an animal becomes a horse now. Now if I call differently, I call cat. Okay. Now cat RB becomes a cat. So that means when you declare this, you can declare as general animal. But when you call, you can actually call a particular animal type. And that's basically called polymorphism, because the polymorphism means when you declare a particular instance, you don't have to decide what kind of animal you want to declare. You can declare as general animal. But when you call, you can call any of the subclass. Okay, you can call cat, you can call horse, you can call tiger, you can call whatever you want to call it. So that means during a declaration, if you are not sure what an animal is. So I'm not sure what an animal is. I just say, oh, it is an animal. But when I actually call the constructor to create the instance, I can actually use any constructor. So that's basically called polymorphism. Okay, that's the idea of the polymorphism. Okay, now this is called polymorphism. You can declare as animal, but you can call as a particular animal, like a cat, a horse, which is a subclass of animal. So you don't have to decide which animal you want to assign to this variable. You can assign this to this variable any type of animal, as far as this animal is the subclass of the general class animal. This is called a polymorphism. Now, polymorphism is very used for, because when you actually do the coding, so when you declare a particular object type, you can declare as a general type. But when you actually try to run it, try to call it, you can call a specific type. Okay. You don't have to decide which type during the declaration of this variable. So that's called polymorphism. Okay. The next topic I want to talk about, maybe I cannot finish it, but I hope you can continue to read this Zai book and try to understand what does mean. It's called abstract classes. Okay. So now in Java, okay, so you can actually define a type of class called abstract classes. Okay. So normally you can define a class, okay, like a bank account, right? Or you can define derived class, and derived class basically inherits all the functionality of the base class. Now in Java, you can define another type. It's called a type of class is called abstract class. Now abstract class is a class that guides the design of subclass, but cannot itself be instantiated as an object. So you can define a class, but you cannot declare an instance of this class because this class is abstract class. There's no such a detailed object for it. Okay. Now, abstract class contains some methods called abstract methods. Okay. So one of the example for abstract class is, for example, if I define a class called shape. Okay. Now, shape is a class. So I can define a kind of shape. But shape is some kind of abstract term. So you really don't, know what does shape represent. So then most case, you can define a shape. And then you can say, okay, I can define a method called get area. Okay, you can define a method called get area in the class shape. But if you don't know what is a shape, how can you calculate the area of the shape? And then the idea for this is because I want you to create a class called like a circle. Now circle, I can define a circle as a subclass of shape. So shape is a base class of the circle. Now for circle, if you try to say get area, so I can override this method get area. Now, can I actually define, can I implement a method for get area? Can I? Can I implement a method? Now for circle, how can I calculate the area? So in circle, I can define radius, right? For circle, I can define, a variable called radius. And then when I calculate the area going to be something like a pi times the square of radius, pi r square. That's the area of a circle. So when I define the radius, I can find out what is the area for this circle, right? So it's pi, which is 3.14 times the radius square, right? Now I can actually calculate the area. But if I ask you the shape, so can I implement and calculate the area for a shape? It's very abstract concept. Now what do you know? What's the shape? And this is a shape, right? And this is a shape. This is also a shape, and this is a shape. So if you don't tell me what specific the shape is, then I cannot call the method. I cannot implement a method called get area, except that unless you tell me what the shape of this. So you can define a class called a circle and extend the shape. And you can define another class called rectangle, which also extends the shape. Rectangle is a shape, right? Circle is a shape, right? So in that case, I can use the concept called abstract class. And the shape is I can define the shape as an abstract class. Now, the syntax for the abstract class is very simple. Okay, so you can use the keyword called abstractor. Okay, so the abstract class, so that means for abstract class like a shape, you cannot say shape, my shape. You cannot create an instance for a shape because shape is an abstract class. Okay, if it's an abstract class, you cannot define an instance. You can say circle, my circle. Okay, so my circle is an instance of a particular circle. And if I actually define the radius of my circle, then I know exactly my circle looks like. But shape is not, because there's no such a thing, a detailed thing as a shape. Okay, so you cannot create an instance for a shape. Okay. Okay, I think I'm almost done with chapter 10, the inheritance. Please actually read the Zai book and just perform the exercises, do some exercises to understand what does the abstract class means. Okay, so abstract class, you know, so the regular class we define, like a bank account or any kind of like a cat or horse, these are normally you can create the instance of for each of these class, and these are called concrete class. Okay, to make it different from the abstract class. So for the abstract class, you cannot create an instance. But abstract class only used to serve as the base class of other class. Okay, so abstract class is only used to serve as a base class of other class, but abstract class cannot be served as a concrete class. That means you cannot create an instance for our abstract class type. You can create the instance of a circle, but you cannot create the instance of a shape. Okay. Now, the syntax for abstract class is pretty simple. We can actually talk about this later, but today I'm actually running out of time. We can actually run another example next time. So we only have maybe 2 more slides left. And so once we finish this, and please start to read the chapter 15. And I'm also going to post a PowerPoint slide for the Java GUI. So and also an example on the blackboard. So we can start to talk about the Java GUI next time. So there's no class on Monday, but we will be back on Friday. So please read this the chapter 10 and also chapter 15 if you can prepare for the Java GUI. So we're going to talk about next time. Okay, I think that's pretty much all.
Thank you.
Thank you.
Thank you. Have a nice week.
Have a nice week.